Hey, did you guys know that Khloe Kardashian is totally into factorizing expressions? Okay, maybe she didn't exactly say that, but she's really into organization, and that's what we're doing today. My name's Miss Danielson, and if you joined us for our last lesson on expanding brackets, we were expanding our minds. Well, today we're taking all those ideas and putting them back away neatly inside our bag. Let's get started. Now, who doesn't love a fresh new pack of pencil crayons? All of them laid out nicely organized. Organization is beautiful. And yet, even as I say organization is beautiful, look at the way that I've written beautiful here. It's not even that organized. It's a bit all over the place. And to be honest, your pencil crayons may look like this on the first day of school in September. I know that by the end of the week, mine looks a bit more like this. And that's okay. There's nothing wrong with that. Sometimes you need to mix things up in order to get things done. So if you joined us last lesson on expanding brackets, we weren't making a mess of things, we were working things out. If you didn't join us for our lesson on expanding brackets, please have a look down in the description box below and go through those lessons first so you understand what we mean when we reverse this process. But first, let me give you an example of expanding brackets where this 5 is directly in front of a bracket, which means that the 5 is multiplying by all terms inside that bracket. To expand those brackets out, we follow the rainbow. So 5 times the first term, 5 times 4 is 20, and 5 times the second term, 5 times 2x is 10x. Remember, terms may be numbers, variables, or both, and they're separated from each other with either a plus sign or a minus sign. So here I've got 20, which is a term which is separated from 10x because there's a plus sign in between them. 20 is a number term, while 10x is a combination of a number and a variable. A term which is directly touching a bracket, usually in the front, multiplies by all terms inside the bracket, as we've just seen here. The number of terms in an expanded expression should match the total number of terms inside the bracket, unless you can simplify. So as you see inside the bracket here, I had 2 terms, and when I multiplied the 5 through, I ended up with an expression again with 2 terms. This time we've got a term which is a number and a variable term in front of the bracket. But 2a is a single term because there's no plus or minus sign in between them. And 2a is directly touching this bracket, so it's multiplying through. First we'll do 2a times the first term. 2a times 4b is 8ab, and 2a times negative 2ab is negative 4a squared b. Again, to quickly go through how we did that, when multiplying terms, we multiply the numbers together. So I did the 2 times the 4 to make the 8, and we do letter times letter. So I did a times the b, which multiplied together just makes ab. To multiply 2 different variables together, we just write them together in alphabetical order. To multiply 2 terms with the same letter variable, we need to consider using powers or indices or exponents. Those are those little numbers up there at the top, as you see here with this a squared. That's because I did 2 times negative 2, number times number is negative 4, and a times ab, letter times letter. A times a, there's 2 a's being multiplied together there, which is why I put this power of 2 here. That's an a multiplied by itself, so there's 2 a's multiplied together, as well as a b being multiplied on. Without the use of brackets, a power, index, or exponent only affects the number it's directly touching, not the full term. So that's to explain that this a is squared because I just done a times a. This is not the 4 getting squared at all here. This time again, I've got a number and letter term out front, 14a squared b. This is all one term, although it's quite a long term, but there's no pluses or minuses in between these numbers or letters. And this term is directly touching the bracket. There is no plus or minus between this term and the bracket, so it's multiplying through both terms inside the bracket. So I'll do 14a squared b multiplied by a. I already have a to the power of 2 here. If I multiply that by another a, that will be 14a to the power of 3b. Remember, that power on that A is only affecting the A. Only the A is cubed, not the 14 and not the B. Again, I'll take the term in front of the bracket and multiply it through by the second term. That's 14a squared b times 3b. Number times number, 14 times 3 is 42. And letter times letter, a squared b times another b will be a squared b squared. Two b's multiplied together. So I'll need a power of 2 on that b. When we move on to reversing this process, we're going to start factorizing these expressions. So we need to know that factors are the values that perfectly divide a number. That's without leaving any remainder, only leaving a whole number answer, no decimals either. Factors come in pairs. When you divide a value by one factor, the result is the factor pair. Factors may be numbers or variables or both. All values apart from 1 have at least 2 factors, being 1 and themselves. So when you think a number has no factors or that two values have no common factors, always consider the value 1 and the values themselves. The term in front of the brackets, when we're expanding these brackets, could be considered the common factor of the expanded expression. So looking at this example 3 up above, the expanded expression has got a common factor of 14a squared b. Both of these two terms could be divided by the number 14, a to the power of 2, and b. Let's start with a simple example for factorizing expressions. Imagine this is Khloe Kardashian, who's got 28 pieces of makeup, 35 pairs of shoes, and 14 pieces of jewelry that she wants to give out to some of her fans. Being a perfectionist, she wants to make sure that each of her gift bags that she gives to each of these fans has exactly the same number of jewelry, makeup, and shoes in it. So how many fans could she make a gift bag for? Let's look at these 3 terms and consider the common factors. I can see that 28a and 14c, these two terms have a common factor of 14, but 35 cannot be divided by 14. So looking at all 3 of those terms, well, obviously we could divide any number by 1, so we could say the common factor is 1, but we want to find the highest common factor. Khloe wants to make the most possible gift bags for her fans. So what's a higher number that we could divide all 3 of these terms by? Write that highest common factor and open a set of brackets. We can divide all 3 of these terms by 7. So Khloe can make 7 gift bags with exactly the same number of pieces of makeup, pairs of shoes, and jewelry inside. Let's work out what 28a would be if we divided by 7. So find the factor pair. 28 divided by 7 is 4. So 28a divided by 7 would be 4a. Write that factor pair inside the bracket. The next term, if I divided it by our highest common factor 7, would leave me with 5b. But don't forget the plus or minus sign that separates the terms from each other. The next term was positive, so our next term will be plus 5b. Next, seeing the 14c, if I divided it by my highest common factor 7, what would that leave inside the bracket? 14c divided by 7 would be 2c. And remember, if there's a plus sign here, don't forget your plus sign there, plus 2c. So Khloe Kardashian could make 7 gift bags for her fans, and each of those gift bags would have 4 pieces of makeup, 5 pairs of shoes, and 2 pieces of jewelry. Now, just to make sure that she's got that right, let's check that we have the correct number of terms inside that bracket. I had a 3-term expression here, and I factored 7 out of each of those 3 terms. So inside the bracket, I should still have 3 terms, and I do. Checking again, make sure that the factorized expression will expand out correctly. So if I were to multiply this through, I know I've got 7 gift bags, I know what I've got inside those gift bags, but did I lose anything in the process? 7 times 4a would make 28a. 7 times 5b would make 35b, and 7 times 2c would make 14c. So it does expand out correctly. One last check. Make sure the terms inside the brackets don't have any common factor apart from 1. So 4a, 5b, and 2c. Obviously all the letters are different, and the numbers 4, 5, and 2, they don't have any common factors apart from 1. 4 could divide by 2 as well as 2, but 5 could not. 5 could divide by 5, but 4 and 2 could not. So we have factorized fully. Let's try some examples now. If you understood that process that we just went through, great. Maybe you want to hit pause, copy these down, and work them out for yourself. But I'm going to carry on working through them with you. So my first step for question A, find that common factor. What can I divide 27x, 18xy, and 45yz by? I can divide them all by 9. So my highest common factor, I put outside the brackets, and inside the brackets, I look for my factor pairs. When I did 27x divided by 9, 27 divided by 9 is 3, so that would leave me with 3x inside the brackets. My second term is a positive term, so I'll put plus, and 18xy divided by 9, well, 18 divided by 9 is 2, so that would be plus 2xy. My third term, 45yz, if I divide that by 9, 45 divided by 9 is 5, so that would be plus 5yz. We can double check that. We can make sure that we have the right number of terms. There's 3 terms in the original expression. There's 3 terms inside the bracket. We can check that if I multiply this through, it would work out. 9 times 3x makes 27x. 9 times 2xy makes 18xy. 9 times 5yz makes 45yz. And we can check that 3x, 2xy, and 5yz don't have any other common factors apart from 1. Okay, let's go on to B. Now B's got some negative signs in there, so let's be careful with that. What's the common factor for all 3 of these terms? I can see the letters are all different, but look at the numbers. Negative 16, negative 12, and positive 24. They could all be divided by 4. So I put my highest common factor outside of the brackets, and I think about the factor pairs that I need to put into the bracket. Now, if you looked at these 3 numbers and you decided to divide them all by 2 instead, you would not be factorizing fully. We always need to use the highest common factor. Okay, so this first term, negative 16u divided by 4, that would leave us with a negative number. That would be negative 4u. Next, negative 12v divided by positive 4, a negative divided by a positive, that would leave us with a negative number, so I need a minus sign between these 2 terms, and it would be negative 3v. And the last term, 24w squared, if I divided that by 4, this is a positive term divided by a positive number, I'm going to put plus, and 24 divided by 4 is 6, so that's plus 6w squared. Again, we do our check. We had 3 terms in the original expression. We have 3 terms inside the brackets. If we multiply this out, 4 times negative 4u would be negative 16u. 4 times negative 3v would make negative 12v. 4 times 6w squared makes 24w squared. And negative 4u, negative 3v, and positive 6w squared don't have any common factors apart from 1. Unless you consider -4. If we had divided the -16u by -4, a negative divided by negative would have given us a positive term inside. If I had divided -12v by -4, a negative divided by a negative would give us a positive 3v. And if I divided positive 24w squared by -4, a positive divided by a negative gives us a negative answer. Either of these two factorized expressions would be acceptable. So it doesn't matter which one you chose. But I would guess that most of you went this way and didn't think to factor out a negative term. Let's have a look at this last example. Look at all 4 terms this time. Note they're separated by these plus and minus signs. What do they all have in common as a common factor? I know you're thinking, oh, they all have A in them, but they don't. This one doesn't have an A. Do they all have B in them? No, this one doesn't have a B. And they don't all have C in them, so forget about those letters. Let's just look at the numbers. 60, 15, 40, and 90. What I notice about all those numbers is they all end in either 0 or 5. Which timetable always ends with 0 or 5? The 5's times table, right? So my highest common factor in this case, is it 5 or could it be something higher? It's just 5. So I put my highest common factor and I open up my brackets to put the factor pairs inside. If I did 60 ab squared divided by 5, I would have some number, ab squared. 60 divided by 5 is 12. Or if you prefer to think 5 times 12 is 60. So 12 ab squared. The next term, 15abc, if I divide by 5, number divided by number, 15 divided by 5 is 3. So that would be positive 3abc. -40, a squared c, divided by 5. First of all, it's a negative number being divided by a positive number. So I'm going to put minus. And 40 divided by 5 is 8. So that's going to be -8a squared c. Finally, 90bc squared divided by 5. A positive 90 divided by positive 5 is going to be a positive factor pair. That's plus 18. Plus 18bc squared. Double check that we've got the right number of terms inside the bracket. Check that it would multiply out correctly. And check that there are no common factors apart from 1 inside this bracket. Those two could both be divided by 3, so could 18, but not the 8. Those 3 could all be divided by 2, but not the 3. So I think we're good. I think we factorized that fully. Time for you to get some practice in now. So go ahead and have a look at these examples. They all have some common factor apart from 1. Find the highest common factor, put that out front, open up your brackets, and put your factor pairs inside. Remember to double check that you've got the right number of terms inside your bracket. Make sure that it would multiply out correctly to give the expanded format that we started with. And make sure you factorize fully so there's no common factors inside those brackets apart from 1. Go ahead and hit pause and try that now, and hit play when you're ready to check your answers. I hope you've had a chance to hit pause. Here come your answers. For question A, the common factor was 2. For B, it was 3. For C, it was 4. For D, it was 5. And for E, it was 2. For F, it was 5. For G, it was 7. For H, it was 10. For I, it was 11. And for J, it was 5. Check those over. Make sure you've got the correct sign between your terms, whether they're plus or minus signs. And let me know if you had any problems with that. Hopefully it went quite smoothly and you're ready to go on to our next lesson, where your factor may not be a number. It could be a variable. Until next time, keep practicing and I'll see you soon. Bye.